What if everything you know, everything you've ever touched, seen, or dreamed about, is not floating freely in a vast and open cosmos, but is instead trapped inside the belly of a cosmic monster? Imagine the universe itself, not as a boundless expanse, stretching forever, but as the inner chamber of a black hole so massive that its edges form the walls of reality. The question sounds absurd at first, almost like the beginning of a science fiction novel, and yet it is a real possibility considered by serious physicists and cosmologists, one that forces us to step outside the comfortable boundaries of common sense and wonder if the very shape of our existence has been misunderstood all along. For most of us, black holes have always been introduced as destroyers. They are those terrifying abysses in space regions where gravity becomes so powerful that even light, the fastest traveler in the universe, cannot escape. In popular imagination, they are villains, mouths of darkness, devouring everything in their reach, swallowing stars whole, ripping apart unlucky travelers who drift too close. The very term black hole is shorthand for oblivion, the end of all stories. But what if instead of an ending, a black hole could be a beginning? What if the endless night around us is not the stage on which black holes appear, but the interior of one colossal black hole itself? This suggestion may feel like an optical illusion, as if we've been staring at a picture for too long, and suddenly the image flips, revealing something completely different. Our ordinary intuition tells us we are outside looking at black holes from afar, peering at them through telescopes and equations. But the unsettling possibility is that we are inside one right now, unable to see the walls of our prison because they are not walls at all, but horizons that bend space and time until the notion of outside loses meaning. Picture the horizon at sea. From the deck of a ship, the ocean seems endless, the world stretching in all directions. Yet you know there is a limit, a curve where the surface disappears from view. A black hole has something similar, an invisible horizon, but with an extraordinary twist. Once something crosses it, there is no going back. This is the event horizon, the point beyond which escape is impossible. And here is the idea that should make your heart skip a beat. What if our universe is already on the wrong side of such a horizon, and everything we see, every galaxy, and every atom is contained within? Consider what this means for your sense of scale. When you look at the night sky, you feel small, fragile, almost insignificant beneath billions of stars. But the suggestion that we are inside a black hole makes us not just small but inverted, like creatures living inside the shell of a pearl, unable to ever touch the world outside. Instead of imagining ourselves floating freely, we must picture ourselves embedded in a fabric, twisted inward by gravity so extreme that space folds back on itself. The stars become lanterns inside a cosmic chamber, their light bouncing across walls we cannot see. It is not only scale that is challenged here, but the very nature of truth. For centuries, human beings have fought to understand the shape of the cosmos. Is it infinite, or finite curved, or flat eternal, or temporary? Each era offered new answers. Ancient myths described a dome or a sphere, a firmament holding the stars in place. Later, the scientific revolution expanded our view, turning Earth into just one planet, circling a star which itself is one among hundreds of billions. The universe we thought was open and boundless, spreading out into an unknown infinity. Yet this new possibility suggests that all along we may have been inside a structure far stranger, its edges hidden, not by distance, but by physics itself. When you imagine yourself inside a black hole, it is tempting to think of claustrophobia, of walls closing in. But the irony is that the inside of a black hole may feel like expansion. To an observer, trapped within space itself, can stretch galaxies, can drift apart, and time can flow, as though nothing unusual is happening. From the inside, the prison looks like freedom. We would never suspect that the reason galaxies recede from us, the reason the universe expands, is because the rules of geometry are warped by being trapped in a cosmic well. This thought flips our perspective. What we interpret as growth, Maybe confinement. What we celebrate as boundless may actually be bounded. Take a moment to let that settle. We are creatures who evolved on a small planet around a modest star who once believed the entire universe revolved around us. Again and again, science has humbled us. We learned that Earth is not the center, that our sun is not special, that our galaxy is just one island in a vast ocean. And now perhaps comes the greatest humbling of all, that our entire universe may be just the interior of something even larger, and that what we call the outside world might not be accessible to us at all. If this is true, then the very idea of knowing the universe takes on a bittersweet taste. We study galaxies, measure cosmic radiation, detect gravitational waves, and we believe we are mapping the whole of reality. But what if we are only mapping a chamber, the way ants might crawl across the inside of a bottle, convinced they understand space itself, while never realizing the glass curves back on them? The tragedy and the beauty of such a realization is that it places us inside a story with no exit. We cannot climb out to see the bottle from above, but we can imagine it, dream it, and chase after hints written into the patterns of light and gravity. And yet, even as unsettling as this may sound, it carries a strange comfort. If we are inside a black hole, then our universe is not meaningless chaos. It is part of something larger, part of a structure that connects beginnings and endings, collapse and creation. A black hole, once feared as annihilation, becomes the womb of existence, its darkness concealing not death but transformation. So the next time you look at the sky, try flipping your imagination. Instead of gazing outward into infinity, imagine gazing inward at the curved surface of an invisible sphere, a surface so far and so distorted that you can never reach it. Imagine the galaxies as floating dust motes inside a glass dome of impossible size. Imagine yourself not as a wanderer in open space, but as a guest in a hidden chamber of the cosmos. Does that thought terrify you, or does it fill you with awe? Perhaps it does both, and perhaps that is the point. Great ideas in science are not meant to comfort, but to shake us, to stretch our minds until they ache. The possibility that we are living inside a black hole is one of those ideas. It asks us to step outside of habit, to challenge what seems obvious, and to accept that reality may be stranger than even our boldest stories suggest. If this truly is the case, if our universe is the interior of a black hole, then the next question becomes unavoidable. What exactly are black holes? And why do they hold such power over the imagination of scientists and storytellers alike? To answer that, we must step back and look at the monster itself, at the strange and terrifying process that gives birth to it. Only then can we begin to see why a black hole might not just be a cosmic grave, but the very home of our universe. Black holes are not simply objects that sit in the night sky like stars or planets waiting to be catalogued in an astronomy textbook. They are thresholds, the ultimate borders between what can be known and what remains forever hidden. When you speak of a black hole, you are not merely speaking of mass or gravity or darkness, but of the very boundary between comprehension and mystery. To approach one is to confront the limits of human understanding, to stare into a place where the language of physics itself begins to falter. A black hole is born from death. Imagine a star far larger than our sun, a fiery giant that has burned for millions or even billions of years. In its core, nuclear fusion battles gravity, creating a delicate balance. For as long as the star can fuse lighter elements into heavier ones, it generates the outward pressure that keeps gravity in check. But eventually the fuel runs out. The nuclear fire sputters, the pressure fades, and gravity, patient and relentless, finally wins. The star collapses inward, and in certain cases that collapse is absolute. The core implodes with such intensity that all matter is crushed to an unimaginable density. The result is a black hole, a singularity surrounded by a horizon beyond which escape is impossible. To describe it another way, think of a trampoline with a heavy bowling ball placed at its center. The ball warps the fabric downward, creating a curve that smaller objects roll toward. This is a simplified image of how mass distorts space-time, an image often used in classrooms. But with a black hole, the bowling ball is replaced with something so dense that the trampoline does not merely dip, it tears folding space and time into a funnel that has no bottom. The metaphor breaks down because no analogy truly captures what is happening. A black hole is not just a deeper curve, it is an entirely different kind of reality. The defining feature of a black hole is the event horizon. This is not a solid surface you could touch or bump against. It is an invisible boundary, a mathematical edge, where escape velocity equals the speed of light. Cross that horizon and no matter how fast you try to run, no matter what rocket or trick you invent, you cannot return. Even light itself, the ultimate messenger of the cosmos, cannot carry word of what lies within. From the outside, anything that falls in seems to freeze time, stretching infinitely as it approaches the horizon. From the inside, the story is very different, but that part is forever hidden from external eyes. This is why black holes hold such an eerie power over the imagination. They are not only traps for matter, they are traps for information. They represent an end to knowledge. You cannot see past the event horizon, you cannot measure or probe what happens beyond. To think of a black hole is to think of a place where science, so bold in explaining galaxies and atoms, must pause and whisper, "Here we do not know." For centuries, humanity feared abysses on Earth, the deep ocean trenches, the caves that descended into blackness. Myths grew up around them, stories of monsters waiting in the dark. In many ways, black holes are the cosmic version of those earthly fears. They are the pits of the universe, the places where even light is lost. In imagination, they become gates to hellmouths of eternal night, bottomless prisons. But here is the twist that unsettles the mind. If our universe is inside a black hole, then what we call reality is itself the dark pit. The supposed doorway to destruction would, from our perspective, simply be the walls of home. Think about the psychological shift this implies. When you look at a black hole from the outside, it is terrifying, a cosmic predator. But from the inside, if you are living there without ever realizing it, you may see nothing unusual at all. Space looks vast, galaxies sparkle, time flows. The horror of the black hole is only visible from beyond its edge, and perhaps we as inhabitants cannot ever stand in that vantage point. It is a reminder that context changes everything, that terror and normalcy can be the same thing depending on where you stand. There is also a deep irony here. Black holes are often portrayed as destroyers, yet they may be the most creative structures in the universe. Their existence challenges physics, fuels, theories of quantum gravity, inspires speculation about new universes budding off from collapsed stars. They spark debates about information entropy and the ultimate fate of reality. Far from being mere monsters, they may be teachers, forcing us to grapple with ideas more radical than we ever expected. And so the image of a black hole as a mouth swallowing light and matter is both accurate and misleading. Accurate because that is indeed what happens at its boundary. Misleading because it reduces the phenomenon to violence, when in truth it is also a revelation. To confront a black hole is to confront the ultimate test of human knowledge. A reminder that there are places in the universe where equations break and certainty dissolves. Pause for a moment and imagine standing near one. You are in a spaceship orbiting the black hole at a safe distance. Ahead of you, the sky bends unnaturally. Light from distant stars curves around an invisible disk, distorted like reflections in warped glass. As you edge closer, time itself stretches, slowing relative to the rest of the universe. To you, minutes pass as usual. To an observer far away, your minutes may become hours, centuries, millennia. It is as if the black hole is not only devouring matter, but time itself, pulling it into its gravity well. This is not science fiction. This is relativity confirmed in mathematics and experiments playing its most dramatic trick. Now imagine crossing the line, falling past the event horizon. There is no explosion, no dramatic moment of impact. You simply pass a point where return is impossible, though you might not even notice it at first. From your perspective, you continue to fall inward. From the outside, however, you appear frozen in place, stretched across the horizon. Two perspectives equally valid, equally real, forever separated by the rules of space-time. This paradox is not only haunting, it is humbling. It reminds us that reality is not a single thread, but a tapestry of viewpoints, each bound by the geometry of the cosmos. This, then, is the essence of a black hole. Not just a place in space, but a borderland between the known and the unknowable. A reminder that nature contains mysteries we may never fully unlock. For many, that thought is frightening. For others, it is liberating. It means there will always be horizons left to chase questions, to pursue enigmas to wonder at. But of course, the question remains, if black holes are so strange from the outside, what lies within them? What is their internal structure? And what does it mean for the nature of space and time? To continue our journey, we must peer past the metaphor of monsters and into the heart of the phenomenon itself. For only by exploring the inside can we begin to imagine whether our entire universe could be living in such a place. Step past the event horizon in your imagination, and you find yourself entering territory that no traveler can ever return from. The outside world has been sealed away forever, and before you lies a mystery that has puzzled the greatest scientific minds for generations. What lies at the heart of a black hole? According to Einstein's general theory of relativity, the answer is chillingly simple and perhaps impossibly strange. All of the mass, all of the energy, every particle and photon that has ever been swallowed is crushed into a single point of infinite density, a singularity. At this point, space-time itself is bent so violently that the very equations of physics break down. Infinity appears in the math, and whenever infinity appears, it is usually a sign that something is wrong or at the very least incomplete. The singularity then is not just a place inside a black hole, it is a symbol of where human knowledge collapses. It is the point at which the known laws of the cosmos wave a white flag and declare that they can go no further. In relativity, this collapse into an infinitely dense point is inevitable. Once matter has fallen inside, nothing stops the collapse. Gravity grows stronger as the radius shrinks, pulling matter tighter and tighter, until all is compressed into nothingness and everythingness at once. That paradox is difficult even to put into words, and yet another great pillar of modern science, quantum mechanics objects. Quantum theory tells us that the universe has a kind of granularity, a smallest possible scale. Things cannot be infinitely small or infinitely dense in the way general relativity predicts. Particles jitter and fluctuate. Space itself may be composed of tiny quanta of geometry, and infinities are forbidden. For quantum physics, the singularity is a nonsensical concept, an artifact of pushing a theory beyond its limit. The clash between relativity and quantum mechanics at the heart of the black hole is one of the deepest unresolved conflicts in science. This conflict is not merely academic. It is a battle of perspectives about the nature of reality. Relativity describes the large, the sweeping motions of galaxies, the bending of light by stars, the slow warping of spacetime by planets. Quantum mechanics describes the small, the uncertain dance of electrons, the probabilistic world of photons, the flicker of particles that appear and vanish in a vacuum. Both theories are stunningly successful in their domains, predicting experiments with uncanny precision, but put them together at the singularity, and they contradict each other violently. It is as if two maps, each flawless in its own territory, overlap and reveal completely different landscapes. For physicists, this contradiction is not simply frustrating, it is tantalizing. It means that something profound is waiting to be discovered, a deeper theory that unifies the large and the small, gravity and quantum mechanics, space-time and probability. The singularity is like a locked door, and behind it may lie the grand unifying vision that has eluded humanity for over a century. The pursuit of this theory of everything is not just an intellectual quest, it is a spiritual one in its own way. To understand what lies inside a black hole is to approach the fundamental code of the cosmos. But let us return to the image of the singularity itself. Imagine standing on the edge of comprehension, peering inward. You would see space collapsing, distances shrinking, time itself accelerating toward a final moment. Every path leads inward. Every trajectory is bent toward the point. In relativity, there is no escape, no detour, no alternative. At the center, the rules end. It is a cliff not into darkness, but into the absence of rules altogether. Now consider what this means if our entire universe is itself the interior of a black hole. What if the singularity we imagine as lying at the center is not behind us but beneath our very feet? What if the Big Bang itself was a singularity, the ultimate compression of all matter and energy into a single point, followed by an expansion that we now call the universe? The parallel is irresistible. A black hole collapses to a point of infinite density, and our universe begins from a point of infinite density. The storylines mirror each other like inverted reflections in a mirror. This idea has profound consequences. It suggests that the birth of our cosmos may not have been an absolute beginning from nothing, but rather a transformation, the internal unfolding of a collapse that occurred elsewhere. To the outside observer, a star collapses and forms a black hole. To the inside observer, a universe is born erupting from a singularity into expansion, time and space. What looks like death from one perspective looks like birth from another. This symmetry, this strange duality, is one of the most mind-bending possibilities in modern thought. Of course, we must tread carefully here. The Big Bang, as understood by cosmology, is not quite the same as a black hole singularity. Our universe did not collapse into a point it emerged from one. The arrow of time points outward rather than inward. But the resemblance is close enough to stir curiosity. Could the singularity at the heart of a black hole be the seed of a new universe? Could each collapse spawn an expansion? Each death give rise to birth? Philosophically, this possibility is both humbling and exhilarating. It erases the notion of a single beginning and replaces it with a cycle, a branching tree of universes. The singularity becomes not just a dead end, but a gateway. And if this is true, then our universe may itself be one branch of a larger structure, a child of collapse, destined perhaps to give rise to children of its own. We are not living in isolation, but in a vast generational family of universes, each born from the singularities of another. Even if this vision is speculative, it teaches us something about the nature of limits. Whenever we encounter a boundary in science, such as the singularity, it does not mean the end of inquiry. It means the beginning of a new kind of question. The singularity tells us that our current theories are insufficient, that the picture we hold of reality is incomplete. It beckons us to look deeper, to imagine beyond, to search for new mathematics, new experiments, new perspectives. In that sense, the singularity is less a barrier and more a signpost pointing the way toward the future of science. So the singularity is both a problem and a promise. It is the breakdown of relativity and the challenge to quantum mechanics. But it is also the spark that drives the search for unification. It is the dark heart of a black hole and the luminous seed of the Big Bang. It is the collapse of knowledge and the invitation to imagine more. And as we linger on this paradox, another question arises naturally. If our universe's beginning resembles the inside of a black hole, then what does that say about the Big Bang itself? Could it truly be that what we call the origin of everything is from another vantage point, just the hidden interior of a collapse? To explore that question, we must turn next to the very first moment of our cosmos, to the mystery of the Big Bang, and ask whether it was in fact the inside of a colossal black hole. The story of the universe has always been told as a tale of beginnings. At the very first moment, the Big Bang, space and time themselves erupted into being. In a fraction of a second, energy poured out in unimaginable quantities, temperatures soared beyond anything we can recreate in a laboratory, and the seeds of galaxies and stars were sown. To us, this event is the ultimate origin story, the genesis of everything we know. But what if this interpretation is incomplete? What if the Big Bang was not the absolute beginning, not a creation out of nothing, but instead the continuation of something else, the hidden inside of a much larger process? Some physicists have proposed that what we call the Big Bang might look from another perspective, like the birth of a black hole. This suggestion radically shifts how we frame the universe. Instead of starting from emptiness, our cosmos could be the byproduct of collapse, a reversal of perspective. Picture a massive star in some parent universe reaching the end of its life. It collapses, forms a black hole, and from the outside all seems lost into darkness. But from the inside, something extraordinary unfolds. On the inner side of the event horizon, expansion takes place. Space stretches, time begins, and what appears as a death from one viewpoint appears as a birth from another. In this way, the Big Bang could be thought of as the mirror image of a black hole, the same phenomenon seen from the opposite side. Consider how strange and beautiful this symmetry would be. To one observer, matter is falling inward toward a singularity space, collapsing under the force of gravity. To another, on the opposite side, space is rushing outward, galaxies are racing apart, and time is flowing in a new direction. Two sides of the same coin collapse and expansion, destruction and creation. This is not simply poetic, it is a serious idea debated among cosmologists. It is a way of reconciling the mysteries of black holes with the mysteries of the Big Bang, suggesting that they are intimately connected. If our universe is the inside of a black hole, then the event horizon of that black hole may form the boundary of our observable cosmos. The beginning we call the Big Bang is the moment of passage, the instant when collapse turned inward into a new expansion. The birth of our universe would then be tied directly to the death of a massive star, or perhaps an even larger structure in some grander reality beyond ours. We are not witnessing the beginning of everything, only the beginning of this branch, this chamber of the cosmic structure. This possibility has implications that ripple outward through both science and philosophy. It suggests that our universe is not unique, but one of many, each born from the collapse of another. Imagine a tree of universes, each black hole in one universe, sprouting into a new cosmos inside. The layers build like Russian nesting dolls, each universe encased within the other, infinitely branching and interconnected. Our universe would be both a child and a parent, both the product of collapse and the seed of future creations. Of course, there are problems with this picture, and physicists are quick to admit them. We do not yet know how to describe what truly happens at a singularity, or whether singularities even exist in the way relativity predicts. Quantum mechanics, with its insistence on limits and uncertainty, may prevent the infinite densities that relativity allows. There may be a bounce instead of a collapse, a rebound of space and time that avoids infinities and produces new universes. The truth is that we do not know. But what is fascinating is how the questions about the beginning of our universe and the fate of matter inside black holes intertwine so closely, as if they are pointing toward the same deeper answer. Think about what this means for the concept of nothingness. For centuries, the Big Bang has been imagined as an absolute beginning, a universe emerging from pure void. But if instead it was the inside of a black hole, then nothingness is an illusion. There was always something, always a before, always another layer. Death and birth are not separate categories, but part of the same process: collapse, giving way to expansion, end feeding into beginning. This does not reduce the mystery of existence, but deepens it, because now we must ask what lies outside. What larger cosmos contains the black hole that birthed us? And is there any way we could ever know? The metaphor of a room inside a larger building is helpful here. Imagine living your entire life inside one chamber with no door or window to the outside. From your perspective, the chamber is the whole of reality. You measure its size, explore its contents, and conclude that this is all there is. But what if the chamber itself is only one room inside a vast structure, a building of unimaginable complexity? Our universe could be that chamber sealed by the walls of the event horizon, beyond which lies a larger world that we cannot reach. We are not outside observers, but inhabitants confined to one inner space. And yet, from our vantage point inside, the universe does not look confined. It looks expansive, even infinite. Galaxies recede, space grows, and the observable universe stretches 93 billion light-years across. It feels like freedom, but it could be the illusion of perspective, the way expansion appears from the inside of collapse. The event horizon is too far away, too distorted by space-time for us to see it as a boundary. To us, it looks like open sky. But perhaps in truth it is the curved wall of a much larger structure. This way of thinking redefines the Big Bang in both scientific and emotional terms. Scientifically, it connects cosmology to the physics of black holes, uniting the mysteries of the very large with the mysteries of the very dense. Emotionally, it transforms the narrative of our origins. Instead of emerging from nothing, we are the continuation of a story that began elsewhere. We are not orphans of the void, but descendants of a greater cosmos. Our existence is not a singular miracle, but one step in an endless cycle of birth and rebirth. Of course, such ideas are still speculative. We do not have the experiments or the mathematics to confirm them. But speculation in science is not a weakness. It is the fuel of discovery. To imagine the Big Bang as the inside of a black hole is to open the mind to new possibilities, to see familiar concepts from fresh angles, and to ask questions that may one day lead to answers. It is a reminder that even our most cherished stories about beginnings are not final but provisional, waiting for the next revolution in thought. So we are left with a tantalizing image. A black hole seen from one side as the ultimate end, from the other as the ultimate beginning. To outsiders, a collapse; to insiders, an expansion. Perhaps the universe is not a singular event, but a hallway of mirrors, each side reflecting the other, stretching backward and forward through time. If that is the case, then we must ask what shape our universe truly has. If it is the inside of a black hole, then its geometry, its boundaries, and its destiny may look very different from what we assume. To answer that, we must turn our attention to the hidden structure of space-time itself and ask, what does the universe actually look like? We often picture the universe in simple shapes because our minds need metaphors to grasp something so immense. The most common one is the balloon. Imagine dots drawn on the surface of a balloon as galaxies, and as the balloon inflates, those dots move farther apart. This is how many of us are taught to visualize cosmic expansion, and for everyday purposes it works. But this neat picture hides a deeper possibility. What if the balloon we imagine is not free floating in space, but actually the inside surface of a black hole? What if the expansion we see as a gentle stretching outward is in some larger sense the mirrored reflection of collapse? This thought pulls at the imagination because it suggests that the true shape of our universe may not be what it seems from within. To explore this idea, we must think about the nature of space-time. Einstein's theory of relativity taught us that space and time are not rigid backdrops, but dynamic, flexible, and curved by the presence of mass and energy. A planet curves the space-time around it, a star curves it more, and a black hole bends it so severely that all paths, even those of light, turn inward. When we look at our universe from the inside, we describe it as expanding, stretching wider with time. But from an outside vantage, if such a perspective exists, the same geometry could be interpreted differently. The expansion we see might correspond to a collapse seen from elsewhere, a curvature so extreme that the meaning of direction itself is transformed. It is not an easy thing to grasp. Our intuition about shapes and directions is trained by everyday experience where up and down, inside and outside are obvious. But in curved space-time, those distinctions blur. Consider the two-dimensional analogy of the balloon again. To us, the two-dimensional beings confined to its surface expansion looks like distance growing between galaxies. They cannot see the third dimension in which the balloon is embedded, so they cannot perceive that their world is actually the inside of a curved surface. In a similar way, we may be trapped inside a higher dimensional geometry perceiving expansion while in the broader structure collapse is taking place. This interpretation would mean that the three-dimensional space we inhabit is not floating in some vast emptiness, but rather forms the inner surface of an event horizon. The horizon itself is not a wall we can see or touch, but a boundary defined by geometry, by what can and cannot escape. We live inside that boundary, and everything we measure, the distance between galaxies, the rate of expansion, the shape of cosmic microwave background radiation, is the evidence of a curved reality projected inward. What makes this idea so captivating is how it reshapes our understanding of cosmic history. In the traditional view, the universe expands outward from the Big Bang. Galaxies move apart and space stretches endlessly. In the black hole interpretation, however, expansion is the shadow of collapse, a projection of inward falling matter and energy into an interior perspective. What seems like outward growth is inward compression turned inside out by the geometry of space-time. To us, it feels like openness, freedom, infinite distance. To an external observer, it may look like the opposite, everything rushing down a gravitational well vanishing into shadow. This duality blurs the line between outside and inside, birth and death, beginning and end. If expansion is collapse, and collapse is expansion depending on perspective, then the shape of the universe is not fixed, but relational. It depends on where you stand, or more precisely on how your experience of space-time is curved. That is both exhilarating and unsettling. It means we cannot simply trust our senses, or even our measuring instruments to tell us the whole story. We may be like the two-dimensional creatures on the balloon convinced of an expanding cosmos, while blind to the larger reality in which our space is embedded. The implications run deep. If our universe is the inside of a black hole, then its geometry is closed, not open. It may loop back on itself in ways that defy ordinary intuition. Straight lines may bend into circles, distances may be finite even when they appear infinite, and boundaries may exist where none seem visible. Our everyday metaphors of balloons and explosions cannot capture the strangeness of this possibility. What looks infinite may actually be curved back upon itself. What looks like expansion may actually be a kind of falling. This perspective also offers a new way to think about cosmic acceleration. Astronomers have discovered that the expansion of the universe is not slowing down as once expected, but speeding up. Dark energy, a mysterious force, is invoked to explain this. But what if the acceleration is not caused by an unknown substance, but is instead a geometric effect of being inside a black hole? The stretching of space-time could be the natural consequence of curvature at the horizon, a manifestation of how collapse looks from within. Instead of adding new ingredients to the universe, perhaps we need only reinterpret the geometry in which we are embedded. Philosophically, the idea forces us to reconsider our place in reality. If we are inside a black hole, then our universe is not the stage for all of existence, but one chamber in a larger structure. Our cosmic story is not absolute, but relative, not the only narrative, but one among countless others. Each black hole in each universe may hold another universe inside, branching endlessly, a fractal of realities nested one within another. We are both infinitesimal and infinite, a point within a point, a cosmos within a shadow. Emotionally, this vision is both humbling and strangely comforting. Humbling because it reveals how limited our perspective is, how much we may be missing about the true shape of things. Comforting because it suggests continuity, a universe born from another, connected to a lineage of worlds beyond our own. The expansion we see, the vast openness of the sky, may actually be the inside of a greater structure, a hidden architecture of space-time that binds us to something larger than we can ever reach. Still, questions remain. Could we ever prove such a theory? Could evidence from within reveal the shape of the universe in ways that betray its hidden nature? Some suggest that imprints in the cosmic microwave background, subtle patterns in the oldest light of the universe, might hold clues. Others look to quantum gravity, the unfinished theory that must unite relativity and quantum mechanics for answers about how horizons and singularities truly behave. The task is enormous, but the reward would be nothing less than the first glimpse of the architecture of reality. For now, we can only speculate using mathematics and imagination to explore the possibilities. To picture ourselves living on the inside of a black hole is to stretch our minds across boundaries of thought, to reimagine the familiar in terms of the impossible. It is an act of wonder, of reaching for truths that may forever lie just out of reach. But even if the answers remain hidden, the questions themselves reshape how we see the universe. They remind us that reality is not always what it appears, that the balloon of space may be the skin of something far stranger, and that our sense of expansion may, in the deepest sense, be an illusion of perspective. And so we arrive at the threshold of another mystery. If the shape of the universe is bound to the geometry of a black hole, then its structure is inseparable from the flow of time within it. To understand expansion, collapse, and curvature fully, we must turn to time itself, the most elusive dimension, and ask how it is bent, twisted, and stretched in the heart of a black hole. Only by facing the mystery of time can we begin to glimpse the deeper truth about the hidden shape of the universe. Time is perhaps the most slippery of all the dimensions, the one that feels closest to us, and yet refuses to be pinned down. We live inside it, move with it, measure our days by its rhythm, and yet we barely understand what it is. In a black hole, time becomes even stranger, almost unrecognizable. Gravity bends not only the paths of planets and light, but the very flow of moments themselves. The closer you get to the horizon of a black hole, the more distorted time becomes, until the difference between 1 second and eternity depends on where you stand. It is as though time is no longer a universal river carrying all boats together, but a set of branching streams, some trickling gently forward, others frozen in place. From the outside, an observer looking toward an object falling into a black hole sees something remarkable. The object never quite crosses the horizon. Instead, it seems to slow down its signals, stretched, its light reddened and dimmed, fading into stillness. The fall appears to take forever, as if the black hole has trapped not just matter but the very flow of time. The horizon becomes a kind of eternal surface, holding everything in a frozen moment. To the outsider, the story ends here. The falling object hovers at the brink, locked in slow motion, while the universe outside continues on. But the story looks utterly different from the inside. To the falling traveler, time feels normal. The heart beats, thoughts flow, clocks tick, and the journey inward continues without pause. There is no sensation of slowing down, no awareness of being trapped in eternity. To those inside, the passage across the horizon is uneventful, ordinary, even like crossing an invisible border with no signpost. The paradox is not felt by the traveler, but only by those left behind watching from afar. This split in perception, this divergence in the experience of time, is what makes black holes so disorienting. Two truths exist at once, each real to the observer who lives within it. If our universe itself is inside a black hole, then perhaps we are living within such a stretched version of time. What we experience as billions of years might be, from some outside perspective, a moment stretched almost infinitely. Our cosmic history from the Big Bang to now could be just the drawn-out echo of an instant scene from another vantage. This possibility is almost unbearable to imagine, because it overturns our sense of duration, of scale, of what it means to have a past and a future. Time becomes relative, not just between individuals or planets, but between universes. The stretching of time inside a black hole is not just a quirk of perspective, but a consequence of the geometry of space-time. Gravity is curvature, and curvature bends the clock. Where gravity is weak, as on Earth, the effect is small, almost invisible, but measurable. Astronauts in orbit age slightly faster than those on the ground because they are further from Earth's pull. On the surface of a neutron star, time runs slower, still drawn out by intense gravity, and inside a black hole, time is pulled nearly to its limit, stretched into shapes we can barely imagine. This stretching is not an illusion, but a real measurable difference, a physical fact of the universe. If we take this idea seriously, then the very age of the universe becomes a question of perspective. We say the universe is 13.8 billion years old, but whose years are these? From outside, the same span could look vastly different, like a single prolonged breath. The lives of galaxies, the birth and death of stars, the long arc of cosmic history might all be no more than a flicker stretched across an infinite horizon. In that case, our sense of antiquity, of depth, may be an artifact of our position, not an absolute truth. The emotional weight of this is difficult to escape. On one hand, it diminishes us. All our striving, our civilizations, our epochs of history, might be nothing more than a pause in a larger story, a ripple in a vast frozen ocean. On the other hand, it connects us to something immense. To live inside stretched time is to participate in a grand slowing, a suspension that reveals the fragility and preciousness of each moment. Every heartbeat, every flicker of thought, every instant of beauty is part of a cosmic elongation, a gift granted by the curvature of space-time. Philosophers have long wrestled with the nature of time, asking whether it flows like a river, whether the past is real, whether the future already exists. Black holes add a new layer to these debates. If time itself can be stretched and slowed depending on gravity, then it is not a single river but many, each winding differently. The present becomes relative, the future becomes ambiguous, and the idea of a universal now dissolves. Our universe seen from within is a story of billions of years. Seen from without, it could be a statue of light and shadow frozen on the surface of a horizon. Both are true, and neither cancels the other. What does this mean for us, if indeed we live inside a black hole's elongated time? It means that our sense of normalcy, our confidence that time flows steadily forward, may be parochial, limited to our perspective. It also means that our fate could be bound to the geometry of the black hole itself. If the horizon defines the limits of our universe, then our time, stretched though it may be, is finite in ways we cannot yet measure. And if singularities await within, then our history is not just long but destined for an end written in the geometry of collapse. Yet perhaps this is not a tragedy but a new kind of wonder. To know that our time is stretched nearly beyond recognition is to realize that existence itself is miraculous, that we are living in the slow unfolding of something larger than we can comprehend. Each moment is suspended in a web of gravity tied to the fabric of space-time itself. Time is not just a backdrop, but an active player sculpted and bent, giving us the chance to live out stories that would be impossible from any other perspective. If this is true, then the next question becomes unavoidable. If time is bent so dramatically inside a black hole, what happens to space itself? If the ticking of clocks can be drawn out almost to infinity, then the distances between points, the shape of geometry, must also be transformed. The stretching of time cannot be separated from the bending of space, because together they form the fabric of reality. To truly understand the hidden architecture of our universe, we must turn our attention to space, to the invisible grid that underlies all existence, and ask how it is reshaped inside the cosmic prison of a black hole. Inside the strange geometry of a black hole, something almost unthinkable happens. The very categories we use to understand reality, the difference between space and time, begin to blur and finally switch places. Outside a black hole, we treat time as the steady march forward, the thing we cannot escape, and space as the expanse in which we can move freely, turn around, or choose a new direction. But cross the event horizon, and those roles trade places. Space no longer offers options. You cannot turn left or right, cannot retreat, cannot choose a different path. Time, on the other hand, does not flow toward the future as you once knew it. Instead, it carries you unstoppably toward the singularity at the black hole's core. What used to be space collapses, while what used to be time becomes a narrow, one-way road with no exits. This idea is almost impossible to picture because it violates our deepest intuitions. We are accustomed to thinking of time as something abstract, invisible, while space is tangible and navigable. Yet in the warped interior of a black hole, this intuition betrays us. Imagine walking across the floor of a room and suddenly realizing that the floor is not flat but funneling downward into a chute. You might think you could resist that, you could step sideways, but there are no sideways directions anymore. Every step you take carries you closer to the center. In a black hole, this is not metaphor but reality. What feels like moving forward in time is in fact motion along a new kind of axis, where the singularity is not just a place, but a moment waiting in your future. Seen this way, the pull of the black hole is not really a force dragging you in. Rather, it is the structure of space-time itself channeling all motion inward. You are not being sucked into a pit but carried along by the new flow of time. Escape is impossible not because you are weak, but because there are no alternative directions to choose. The singularity is not somewhere you might go, it is when you must go. It lies ahead of you, in the same inevitable way that tomorrow lies ahead of today. This inversion of roles has profound consequences for our understanding of freedom and destiny inside a black hole. Outside, we can imagine trajectories, arcs of motion paths that diverge and intersect. Inside, all paths converge. Everything, no matter how it moves, is heading to the same destination. From the perspective of physics, this makes sense because the singularity is where the equations of general relativity drive all matter and energy. But from the perspective of human imagination, it is haunting. To live inside a black hole is to live inside a funneling of reality itself, a narrowing of all possibilities into a single, unavoidable outcome. If our universe is indeed the inside of a black hole, then this reversal of roles may explain one of the deepest mysteries we face. Why can nothing escape the universe? Why does every particle, every galaxy, every beam of light remain within its boundaries? Perhaps it is not a matter of being trapped, but of moving along the inevitable timeline defined by our cosmic horizon. We are not prisoners in a cage, we are travelers on a road, and that road by its very geometry leads inward. This also reframes the way we think about expansion. We often say the universe is expanding galaxies, rushing away from one another as space itself stretches. But if space is collapsing inside a black hole, what appears to us as expansion might be a different kind of distortion, the inside-out reflection of a collapse viewed from within. From our perspective, space grows wider, galaxies drift farther apart, the cosmos balloons outward. From the outside, what may really be happening is a contraction, everything funneling inward toward a center. The paradox is that both views are true depending on which side of the horizon you occupy. There is something almost poetic about this inversion. It reminds us that the categories we rely on, space, time, direction, distance, are not absolute. They are malleable, shaped by gravity, bent by curvature, rearranged by the invisible architecture of the cosmos. To step inside a black hole is to enter a place where the rules of common sense dissolve, where what was once space becomes time, and what was once time becomes a path to an ending you cannot avoid. In a sense, it is the most radical redefinition of reality possible, and yet it flows directly from the mathematics of Einstein's theory. The human imagination resists this because we are wired to think of space as where things happen and time as when they happen. But physics suggests that these are not separate categories but parts of a single continuum. Inside a black hole, this continuum twists so radically that our language breaks down. The floor becomes a wall, the horizon becomes a barrier of perspective, and the singularity becomes less like a place you might reach and more like a moment that reaches you. And yet, hidden inside this strangeness is a lesson about our own universe. If the inside of a black hole reshapes space and time in such a profound way, then perhaps our entire cosmos is shaped by the same logic. Perhaps our sense of moving freely through space is already constrained by deeper geometries we cannot see. Perhaps the inevitability of time, the sense that the future pulls us onward, is not just a property of our minds, but a reflection of cosmic structure. If so, then our universe is not merely a stage on which events unfold, but a dynamic architecture in which space and time themselves evolve, sometimes in ways that invert everything we thought we knew. This realization leads naturally to a new question, one that stretches beyond the boundary of a single universe. If black holes invert the roles of space and time, and if our universe might itself be the interior of such a structure, are we unique? Is there only this one inside this one cosmic chamber? Or are there countless others, each hidden within? Black holes scattered across realities, each with its own geometry, its own version of space and time, its own destiny. To consider that possibility is to expand our imagination beyond a single universe into a multiverse of horizons, each containing worlds as strange and vast as our own. And it is toward that possibility that our curiosity now turns. When we contemplate the possibility that every black hole in our universe might contain an entire universe of its own, we enter a realm of thought that feels more like myth or poetry than physics. And yet this idea arises not from fantasy, but from the logical extension of our theories. A black hole, after all, is a place where space-time itself folds in on itself, where the normal rules are broken, where beginnings and endings intertwine. If the singularity is not the end of a story but the start of another, then perhaps every black hole is a seed, and every seed gives rise to a new cosmos blooming in darkness. Imagine our universe as a vast cosmic tree. Each branch is a black hole, and from each branch grows another universe. Those child universes in turn sprout their own black holes which blossom into new realities and so on endlessly. It is a cosmic genealogy, a family tree of worlds, each nested within another like the wooden figures of a matryoshka doll. This vision reshapes the very idea of creation. The Big Bang was not the one-time birth of everything, but simply the germination of a branch in an infinite forest of universes. Our cosmos in this picture is neither the first nor the last, but one member of a lineage stretching back without beginning and forward without end. Such a perspective changes how we think about black holes themselves. They are not merely destroyers swallowing stars, planets, and light, erasing them from existence. They are also creators, wombs of possibility. From the outside, a black hole looks like an end. From the inside, it might feel like a beginning. To fall into one may be in some sense to fall into the foundation of another world, though we would never live long enough to see it. The paradox is that destruction and creation are not opposites here, but different faces of the same process. One universe collapses, another is born. Of course, this idea is still speculative. The mathematics of general relativity tells us that singularities exist, and the equations suggest that new regions of space-time could in principle emerge from them. Quantum mechanics complicates the picture, raising questions about what happens to information, whether it is truly lost or somehow preserved. Yet the beauty of this hypothesis lies not in its certainty, but in its possibility. To imagine that black holes could be doorways to new universes is to grant them a role that unites science with myth, transforming them from cosmic monsters into cosmic midwives. The nested multiverse, if real, would be fundamentally different from the popular idea of parallel universes. In the parallel model, countless universes exist side by side like pages in an infinite book, unaware of one another. In the nested model, they are linked like generations in a family, each universe giving rise to children that carry pieces of their parents' legacy. Perhaps the physical laws themselves, the constants of nature, the balance between forces are passed down through this cosmic inheritance, varied slightly with each birth. Our universe may carry the imprint of the one before, just as a child resembles a parent, but is never identical. This has a haunting implication. If universes can reproduce through black holes, then those with laws that favor the formation of black holes will give rise to more descendants. This idea, known as cosmological natural selection, suggests that universes like ours, rich in stars and heavy elements, might be common precisely because they are fertile. We live in a universe that makes black holes, and because it does, it also makes more universes. In this sense, the cosmos evolves not only across time, but across layers of reality itself. What does it mean for us living within one branch of this vast tree? It means that our universe may not be the only story, and perhaps not even a particularly unusual one. It means that the end of everything we know, the collapse of stars into black holes, may not be endings at all, but the beginnings of stories we will never read. It means that the grandeur of existence stretches far beyond the horizon we can see, branching into hidden layers where other realities bloom unseen. For the human mind, this is both humbling and exhilarating. Humbling because it reminds us that we are small, that even our universe is just a room inside a larger house, which itself may be a chamber inside an even larger structure. Exhilarating because it suggests that the story of existence is infinitely richer than we can imagine, filled with hidden worlds, each with its own mysteries, its own stars, its own forms of life, perhaps. To contemplate this nested multiverse is to stretch the imagination to its breaking point, to glimpse infinity reflected within infinity. And yet a question lingers. If universes are nested within black holes, if reality is structured like dolls within dolls, can one layer ever glimpse another? Can beings like us ever see beyond the boundaries of our own horizon to peer into the universe that birthed us, or into the universes we may unwittingly give birth to? Or are we forever sealed within our layer, condemned to speculate about the others without ever touching them? This question pulls us forward toward the edge of our knowledge, inviting us to wonder what lies beyond the walls of our cosmic chamber and whether escape or revelation is possible at all. The idea that black holes might be connected to something else, something not of destruction but of release, is one of the most daring concepts to come out of the marriage between mathematics and imagination. In the 1932nd, Albert Einstein and his collaborator Nathan Rosen explored a peculiar solution to the equations of general relativity. What they found was that, under certain conditions, space-time could be described not as a simple curvature, but as a tunnel, a bridge linking two distant regions together. This theoretical structure became known as the Einstein-Rosen bridge, or more commonly today, the wormhole. At its most poetic, it is the suggestion that what goes into one end of a black hole might not simply vanish into nothingness, but instead re-emerge somewhere else in some other domain of space-time. At the heart of this idea lies the strange partner of the black hole, the so-called white hole. If the black hole is a region where nothing can escape, a place of ultimate consumption, then the white hole is its mirror image, a region where nothing can enter, only burst outward. In principle, the two could be connected, black hole swallowing white hole, spewing a hidden passage between two realms. This notion is both tantalizing and unsettling. It imagines that our universe is threaded with secret tunnels invisible to us, which may link beginnings and endings in ways we cannot directly perceive. Of course, there is a catch. The mathematics that describes these bridges also tells us that they are profoundly unstable. In their natural state, they collapse before anything can cross. The throat of the wormhole pinches shut almost instantly, like a bubble bursting as soon as it forms. To hold one open, it would require a form of matter with negative energy, something exotic that no one has ever seen in reality. Without this, the Einstein-Rosen bridge remains a doorway that closes the instant it is opened, more a metaphor than a passage. Yet metaphors are powerful, and sometimes they contain truths we cannot otherwise see. If a black hole were linked to a white hole, then what we call the Big Bang might not be an absolute beginning at all, but simply the other side of such a bridge. Imagine our universe exploding outward, not from nothingness, but from a funnel of space-time, a release of energy and matter that once fell into another realm. What we experience as creation could be in another perspective, the echo of destruction. The birth of our universe might be the death throes of another. This changes the way we think about time itself. In the classical picture, time has a direction, a clear before and after. But in the wormhole vision, before and after lose their absolutes. The end of one world becomes the start of another, not through a line, but through a loop, a bridge that makes beginnings and endings inseparable. The question, what happened before the Big Bang, might be answered not with silence, but with the collapse of something else. Our origin story would no longer be a singular spark, but a transfer, a handoff in the eternal relay of universes. There is a peculiar symmetry in this. Black holes terrify us because they seem like ultimate endings, places where all roads stop. White holes, though hypothetical, provide the opposite, ultimate beginnings where all things surge forth. If they are two sides of the same structure, then perhaps endings and beginnings are illusions of perspective. To an observer on one side, a star falls into darkness and disappears forever. To an observer on the other side, that same energy bursts forth in a dazzling eruption, a cosmic genesis. What is annihilation here is creation there. Some physicists have entertained this possibility more seriously than others. The equations of general relativity allow it. Quantum mechanics complicates it. Observational evidence, as of yet, is absent. But the very act of contemplating such bridges forces us to question our deepest assumptions. We think of the universe as a self-contained whole, but what if it is only half of a structure linked invisibly to something else? What if the fabric of existence is stitched together by tunnels, unseen seams binding the quilt of reality? The implications spill into philosophy as well as physics. If our universe is the outflow of a white hole, then we are inheritors of another cosmos. Our existence is not self-generated, but handed down, not unique but part of a cycle. This suggests a continuity across universes, an eternal chain of birth and death, where the meaning of beginning is always relative. To ponder this is to blur the line between science and myth, for what could be more mythic than the thought that our world is the child of another, born through a hidden passage no one can ever traverse. And yet one cannot help but wonder what it would mean to find such a bridge, to peer into the throat of a wormhole and glimpse the other side. Would we see another cosmos in its infancy, a fiery expansion unfolding? Would we see the ashes of a universe that has already burned away? Or would the very act of trying to look destabilize the bridge, collapsing it before our eyes? Perhaps the instability of wormholes is a cosmic safeguard, a way the universe ensures that these passages remain closed, that no one may step between realities. Still, the thought lingers. If the Big Bang is the other mouth of an Einstein-Rosen bridge, then our universe is not isolated, but connected. The veil between birth and death, between in and out, is thinner than we think. In this vision, creation is not a singular miracle, but a recurring rhythm, a cosmic breath that expands, collapses, tunnels, and expands again. Each inhalation leads inevitably to an exhalation. Each collapse plants the seed of an explosion. We are living in the exhale of something else's inhale, the beginning that is secretly an end. If so, then the story of existence is not linear but cyclical, not a straight path but a bridge with two ends. And perhaps, just perhaps, the greatest illusion we hold is that beginnings and endings are separate things at all. If Einstein and Rosen were right, they may be one and the same, joined invisibly by a passage we cannot see, but which may define the destiny of everything. When we imagine the universe, we often picture it as a story with a clear beginning and a definite end. It opens with a grand prologue, the Big Bang, and depending on which theory you favor, it concludes with a silent freeze, a fiery collapse, or a slow decay into darkness. But there is another possibility, one that changes the way we think about the cosmos entirely. What if black holes, those supposed tombstones of stars and galaxies, are not final resting places at all? What if they are gateways not just to destruction but to rebirth? In this view, death in the universe is never absolute, but merely a transition, a doorway through which new realities step into existence. We know the story on the smaller scale. A massive star, after burning for millions or billions of years, exhausts its nuclear fuel. Gravity, relentless and unopposed, takes over, crushing the star inward until its core collapses. The result can be a neutron star, an unimaginably dense city-sized remnant, or in the most extreme cases, a black hole. Here matter, once radiant and free, becomes imprisoned within an event horizon, light itself unable to escape. To us, it looks like an ending, a one-way descent into silence. But if the speculations of some physicists are even partly true, this collapse might also mark a beginning, the seed of a universe hidden within. The logic is strangely symmetrical. If the Big Bang was the expansion of all space, time, and matter from an infinitely dense point, then the creation of a black hole appears to mirror that process, in reverse, matter rushing inward, compressed into something unfathomably small. Seen this way, the two events, collapse and explosion, are not opposites, but two phases of the same cosmic cycle. A star's death gives birth to a black hole. A black hole's ultimate fate could give birth to a new cosmos. Perhaps our universe itself is the descendant of some long-vanished star from another realm, its final act, becoming the spark that lit our beginning. This idea reframes the way we think about cosmic mortality. What we call death in the universe may be more akin to transformation. Just as the death of stars creates the heavy elements that make planets and life possible, the death of black holes could create entire new realities. In this vision, there is no such thing as ultimate extinction. Instead, every apparent ending is a threshold, every collapse a passageway. Black holes become not the terminus of existence, but the wombs of universes, dark crucibles, where destruction and creation blur together. Consider what that means for our own universe. If we imagine it not as a singular, unrepeatable event, but as one child in an endless lineage of cosmic births, then the very concept of the beginning becomes relative. What we call the Big Bang might simply be the outward bloom of a collapse that happened elsewhere beyond our reach. And when our own universe one day faces its demise, whether through expansion into eternal emptiness or a slow unraveling into heat death, it may not be an end, but a transformation. Perhaps its scattered energy and fading light will collapse inward again, drawn into black holes that grow larger and larger until they dominate everything. And perhaps from those giants, new universes will someday spill forth. The chain would continue infinite and unbroken life from death, death from life. This vision is not merely poetic. It is supported at least in part by the mathematics of general relativity, which does not forbid such cycles. It is also fueled by the strange paradoxes that black holes introduce. If nothing can escape, where does the information about what fell in go? Does it vanish forever, or is it somehow preserved, encoded in the birth of something new? These puzzles suggest that black holes may not be silent vaults, but active participants in the unfolding story of reality, recycling the debris of one cosmos into the foundation of another. And there is something deeply human in this idea. We are creatures who fear endings, who see in death the closing of doors. Yet here, at the largest scale imaginable, the universe whispers a different message, that endings may only ever be beginnings disguised. A collapsing star becomes a black hole becomes a universe, and so on in a cycle that has no first chapter and no final page. It is a story without edges, a book that rewrites itself endlessly. If this is true, then the word death loses much of its sting. The collapse of a star is not tragedy but metamorphosis. The disappearance of matter into a black hole is not erasure but transition. Even the eventual fading of our own universe may not be a cosmic doom, but the prelude to another awakening, one we will never see, but which will carry forward the energy and essence of all that came before. The universe does not die. It transforms. This possibility forces us to confront the meaning of our place in the cosmos. If universes are born and die like stars, then ours is not unique. We are not living in the first reality nor the last. We are simply one link in an eternal chain. And if that is true, then our existence is not fragile, but deeply embedded in a greater cycle of renewal. We are, in a sense, immortal, not as individuals, not even as a species, but as participants in a cosmic rhythm that never truly ceases. Of course, these are speculations. We have no direct evidence that black holes give birth to universes. We cannot peer inside their horizons nor follow them to their ends. Yet the mere act of considering this possibility expands our imagination. It teaches us that the universe may be stranger than endings, kinder than annihilation. It suggests that the darkness we fear most may conceal the greatest light of all. And so we return to the idea with which we began, that black holes, far from being tombstones, might be gateways. A star dies, and a black hole is born. A black hole dies, and perhaps a universe awakens. In this cycle, death is never final. It is always the opening of another chapter written in a language we cannot yet read. To live in such a cosmos is to live in hope, for it means that nothing, not even the universe itself, is ever truly lost. But if this is so, if endings are truly beginnings in disguise, then we must ask, what force drives these transitions? What power takes collapse and turns it into expansion, silence and turns it into song? Our universe is still growing, still. stretching outward at an accelerating pace, and behind this strange expansion lies a force we do not yet understand. To grasp the next piece of the puzzle, we must turn our attention to the most mysterious player of all, the unseen hand guiding the fate of the cosmos: dark energy. The universe is not only expanding, it is accelerating in its expansion. Galaxies are rushing away from one another faster and faster, as if some hidden hand is pushing them apart, stretching the very fabric of space-time. When astronomers first discovered this acceleration in the late 20th century, it was nothing short of shocking. The expectation had been that gravity, though weakened by distance, would at least slow the universe's growth over time. Instead, something else, something invisible and inexplicable, was working against gravity, overpowering it on the grandest scale imaginable. This force has been given a name, though the name tells us little: dark energy. Dark energy is not energy in the ordinary sense, like the heat from a flame or the charge in a battery. It is not something we can hold, touch, or even directly measure. It is rather a placeholder for our ignorance, a way of naming the phenomenon of cosmic acceleration without yet knowing its cause. Yet despite our ignorance, we can estimate its influence, and that influence is staggering. Roughly 70% of the universe, by the best current measurements, is made of this unseen force. Everything else, galaxies, stars, planets, even black holes, accounts for a mere fraction of the whole. In other words, what we think of as the universe is mostly not matter at all, but this mysterious expansionary pressure humming invisibly in the background. Now here is where the imagination begins to blur with theory. If we entertain the possibility that our universe is the interior of a black hole, then dark energy may not be some arbitrary cosmic feature, but the natural expression of that deeper geometry. Think of it this way: a black hole, as we understand it, creates immense pressure at its core, bending space-time into a funnel from which nothing can escape. But if you are inside, if your perspective is not of falling into the abyss, but of living within its warped interior, then that pressure may appear not as collapse, but as expansion. In other words, the same mechanism that swallows matter from one perspective may drive cosmic growth from another. Dark energy might then be the echo of a black hole's internal pressure, the breath of a hidden structure that sustains our reality from within. Seen in this light, the accelerating expansion is no accident. It is simply what it feels like to exist in a space-time bubble that is forever stretching, unable to collapse, because the rules of geometry and pressure inside a black hole demand it. Our universe may be a balloon that never deflates, endlessly inflated by forces we cannot see but constantly experience. The expansion is not optional, it is structural. It is the way this kind of universe must behave. The implications are profound. For one, it means that the universe may never shrink back into itself, never return to some fiery singularity in a big crunch. Instead, the very conditions of its birth guarantee that it will keep growing, perhaps forever. Galaxies will drift farther apart until their light can no longer reach one another. The stars will burn out and the cosmos will grow darker and lonelier. But the expansion will continue unstoppable, because it is written into the very identity of the space we inhabit. We live in this vision in a prison without walls, a chamber that grows larger and larger, but from which there is no escape. And yet prison might not be the right word. For a prison suggests limitation, confinement, a sense of boundaries that can be touched. Our universe may not have any such edges. Its expansion does not push against anything, does not meet resistance. It is not as though galaxies are rushing into pre-existing empty space. Rather, space itself is unfolding, the distances between points increasing because space-time itself is stretching. If dark energy is the breath within this unfolding, then what we experience is not the growth of something into nothingness, but the perpetual redefinition of what space means. There is no outside to rush into, no beyond to reach. The universe expands not into space, but as space. This makes the concept of escape meaningless. If we are indeed inside the interior of a black hole, then the expansion we experience is the interior geometry working itself out. There is no door, no tunnel, no passage leading beyond. The event horizon is not a boundary we might someday reach and cross. It is a condition of existence itself, a horizon that recedes forever, because the universe itself is its interior. This is why some physicists imagine that we live inside an inflating balloon that never bursts, one that grows faster the larger it becomes, fueled by the mysterious force we call dark energy. It is a strangely poetic picture. Dark energy, invisible and pervasive, acts like the breath of the cosmos, the steady rhythm that ensures its growth. If gravity is the universe's heartbeat pulling matter together in pulses of collapse and formation, then dark energy is the universe's breath, expanding the lungs of space-time with each passing moment. Together, these two forces shape everything we know. Without gravity, there would be no stars or planets, no galaxies, no structure at all. Without dark energy, the universe might never have grown beyond a dense hot cloud, never become a place vast enough to allow complexity and life to emerge. But here lies the tension. If dark energy continues to dominate, then the universe may be headed toward a fate of eternal expansion, a reality where galaxies grow so far apart that the night sky goes dark, where stars burn out without replacements, where black holes evaporate slowly into nothing. In such a future, the universe is not destroyed by collapse, but emptied by growth, a desert without end. Yet even this picture may not be final, because if black holes can give rise to new universes, then the expansion we now endure may simply be part of a greater cycle, one we cannot see, but are deeply woven into. And this brings us to the most unsettling and fascinating question of all. If dark energy is the breath that keeps our universe inflating, is there any limit to this process? Does expansion ever stop, or does it stretch on forever, creating a cosmos without edges, without end, without borders? The thought is both exhilarating and terrifying. To live in an infinite, boundless universe is to live in a reality that defies the very categories of beginning and end, of inside and outside. It is to exist in a place where even the concept of a limit may be an illusion. The more we learn about dark energy, the less it feels like an answer, and the more it feels like a doorway, a mystery that leads us deeper into the unknown. It explains the acceleration, yes, but it also raises profound questions about the nature of our universe. Are we truly trapped inside a bubble that can never be escaped? Are we destined to live in an ever-expanding chamber that grows colder and darker but never bursts? Or is expansion itself only one phase of a larger rhythm, one that we have not yet lived long enough to perceive? What is certain is this: the universe breathes. We feel it in the recession of galaxies, in the faint ripples of ancient light, in the steady hum of space-time itself. It is a breath drawn not in air but in geometry, a rhythm that defines existence at its most fundamental. To call it dark energy is to acknowledge both its reality and our ignorance, to name what we cannot yet know. And as we ponder its meaning, we find ourselves drawn toward the next great question, the one that has haunted humanity for as long as we have gazed at the stars. If the universe breathes without end, if it expands without boundaries, then we must ask, does it have an edge at all? Is there a limit to this vastness, or are we adrift in an endless sea with no shore in sight? There is a boundary to our vision of the cosmos, a horizon we can never cross. No matter how powerful our telescopes become, or how far our technology advances. It is not a limit of glass and mirrors, or a problem of engineering. It is a wall woven into the fabric of reality itself, a boundary created not by human failure, but by the rules of physics. This wall is the cosmic horizon, the furthest edge of what we can ever see, and in many ways, it acts as our universe's own event horizon. Imagine standing on a shore, gazing out across a vast ocean. The water stretches on until it meets the sky, forming a line at the limit of your vision. You know rationally that the sea continues beyond that line, but from where you stand it seems as though the world simply ends there. Our universe is much the same. The night sky may glitter with stars and galaxies, but beyond a certain distance light has not had enough time to reach us. The cosmos has only existed for a finite span, roughly 13.8 billion years, and light travels at a finite speed. This means there is a maximum radius to our vision, a cosmic shore, beyond which no signal, no message, no glimmer of existence can arrive. But this boundary is not simply about time and distance. Because the universe is expanding, galaxies beyond a certain threshold are rushing away from us faster than light itself, carried along by the stretching of space. Their light is forever trapped, unable to bridge the growing gulf. In practical terms, this means that there are regions of the universe we will never under any circumstances observe. Not now, not in 10 billion years, not with any future technology. Those regions are lost to us in principle, not in practice. They are on the far side of the cosmic wall. And here is the astonishing thought. If our universe is indeed the interior of a black hole, then that cosmic horizon is not merely a mathematical boundary, but our own event horizon. Just as nothing inside a black hole can send signals beyond its boundary, so too are we sealed within a finite bubble of visibility, hemmed in by a horizon that represents not just what we cannot see, but what we cannot ever touch. The edge of our observable universe is in this vision the black surface of a vast cosmic event horizon surrounding us like an invisible sphere. It is not a border in space, but in causality itself. What lies beyond that is the most haunting question. Our instruments cannot probe it. Our equations struggle to describe it, and yet we know instinctively that the cosmos must continue. The galaxies we see are likely only the nearest islands in a far greater archipelago. Beyond the horizon may lie countless others, stretching on in patterns we cannot begin to imagine. Some regions may look familiar, filled with galaxies and stars, not so different from our own. Others may be radically strange, with different distributions of matter, or perhaps governed by slightly altered physical laws. But whether familiar or foreign, they are forever sealed away, as unreachable to us as the heart of a black hole is to an outside observer. This is the sobering beauty of the cosmic horizon. It shows us both the grandeur of the universe and the smallness of our place within it. Our vision, vast as it feels when we gaze at the night sky, is only a fragment of the whole. The cosmos is like a great novel of infinite length, but we are forever confined to a single chapter, unable to flip the page. We can wonder, speculate, dream about what lies beyond, but the story there will never be ours to read. Yet rather than diminishing us, this limit deepens the mystery of existence. It tells us that we are not standing at the center of all that is surveying creation in its entirety, but that we are participants in a reality larger than our minds can encompass. The cosmic wall humbles us, reminding us that knowledge is always partial, that every glimpse into the universe is also a reminder of what remains hidden. It is the horizon not just of light, but of meaning. And so we find ourselves asking whether this horizon defines the true size of the universe, or merely the visible size. Is reality finite, wrapped tightly around us like a sealed chamber? Or does it extend without end, infinite in scope, with our observable patch being nothing more than a tiny window? If the latter, then the horizon is less a wall than a veil, a curtain beyond which reality stretches endlessly. But from our perspective, curtain or wall, the effect is the same. We cannot cross it. Physicists sometimes describe the observable universe as a bubble, and this metaphor is apt. We are inside a vast soap bubble of light floating in a much larger space we cannot touch. The surface of the bubble marks the farthest signals that have ever reached us, beyond that silence. And if the bubble itself is the interior of a black hole, then what surrounds it is even stranger than silence. It is the unseeable, the unreachable, the unknowable. The presence of this cosmic wall forces us to reckon with the limits of science itself. For all our ingenuity, for all the power of mathematics and telescopes, there are truths that may forever be out of reach. This is not a matter of technology catching up, but of the universe itself drawing a line. Beyond the event, horizon information cannot flow to us. Reality in that sense is censored. We can write equations to imagine what lies beyond. We can build simulations to approximate it, but we will never have the direct evidence we rely on in every other domain of science. The ultimate frontier is not one we can explore. This changes the way we think about existence itself. If there are vast regions of the universe beyond our view, then what we call the universe is not reality in its entirety, but a local neighborhood. We are provincials in a cosmic empire, living in one district among countless others, cut off by walls we cannot scale. And if black holes birth universes, then each bubble may be only one among an infinite nesting of others like Russian dolls, stacked one inside another, each sealed within its own event horizon. Still, even as we confront these limits, there is something profoundly human about pushing against them with imagination. To recognize the horizon is not to surrender curiosity, but to sharpen it. Knowing there are things we cannot see makes us ask new questions, seek new metaphors, and stretch our minds further. Perhaps the very act of knowing we are walled in is what gives us the courage to imagine what lies beyond. And in the end, the cosmic horizon is not just about physics, it is also about meaning. For once we recognize that our universe is bounded by darkness, we cannot help but wonder about our place within it. Are we insignificant specks trapped in a cosmic chamber, or are we rare witnesses of the universe's own self-awareness, beings able to look toward the horizon and name it? The wall does not only mark the limit of what we can see, it also forces us to confront the limits of who we are and what it means to exist in a reality so vast, so silent, and so full of mystery. And this leads us naturally into the next question, one that is not about galaxies or horizons, but about us. If the universe itself is sealed within darkness, if our view will always end at a horizon we cannot cross, then what does that say about humanity? What meaning can a small, fragile species carve out in a cosmos that seems determined to hide itself from our gaze? In the grand scale of the cosmos, our existence can feel almost unbearably fragile. We are perched on a small planet, orbiting an ordinary star tucked away in a modest arm of the Milky Way galaxy, which itself is but one spiral among hundreds of billions. That galaxy, in turn, drifts through a sea of other galaxies bound together in clusters and filaments that stretch across space like cosmic webs. And all of this vast scaffolding of matter and light, all the beauty of stars and nebulae, is dwarfed by the oceans of dark energy and dark matter that dominate the universe. Against such immensity, we are little more than a speck, a whisper, a grain of dust, suspended in the belly of a cosmic giant. It is tempting, when confronted with this scale, to collapse into a sense of insignificance. After all, if everything we have ever known and loved, every poem ever written, and every thought ever dreamed, is confined to one tiny corner of an unfathomably larger reality, how could any of it matter? The galaxies blaze and vanish without heed to us. Black holes swallow stars by the millions, and the universe stretches ever outward, heedless of our struggles. To the indifferent expanse of space-time, human life seems like a flicker in the dark, soon gone and soon forgotten. Yet here lies the paradox. Our very smallness, our fragility, is precisely what makes us precious. Out of all the countless stars and the endless gulfs of space, we are among the rare configurations of matter that have achieved awareness. We are the universe thinking about itself, a fleeting pattern in the cosmic sea that has for a moment learned to see, to wonder, to ask why. If stars are the eyes of the night sky, then consciousness is the eye of the universe itself, turning inward and glimpsing its own reflection. This realization transforms the metaphor of insignificance. Yes, we are tiny, but we are not trivial. Dust we may be, but we are dust that dreams. The very fact that we can look into the darkness and recognize it as darkness, that we can stand on a pale blue dot and imagine the abyss that surrounds us, gives our existence a strange, profound weight. If no other species in the cosmos has done this, then we are unique beyond measure. And even if there are countless others scattered through the galaxies, the fact remains that here and now, in this sliver of space-time, we are awake. Our stars and planets may be ripples in a great unseen ocean, yet within those ripples exists thought, memory, art, love. From the silence of the void, life has found a way to sing. The atoms forged in stellar furnaces have, through the long patience of evolution, arranged themselves into beings who can ponder their own origins. In that sense, every human mind is an improbable victory against entropy, a lighthouse flickering in a sea of night. Consider what this means for the universe itself. Without consciousness, the cosmos is mute, an endless unfolding of physics without witness or meaning. But with consciousness, even if only in isolated sparks, the universe becomes a story. Its stars and galaxies are not only there, but they are seen. Its mysteries are not only present, but they are questioned. Through us, the universe has found a way to gaze upon itself and ask, "What am I? What does all this mean?" That is no small thing. It is in many ways everything. And perhaps that is the true purpose of being small. If we were vast, if we stretched across galaxies as effortlessly as the dark matter filaments, we might not need to wonder. Our awareness might dissolve into the scale of the cosmos itself. But because we are finite, fragile, and bounded by mortality, we are compelled to search for meaning. We cling to each moment knowing it is fleeting. We treasure connection, knowing how easily it can be lost. Our smallness makes us yearn, and in that yearning lies our greatness. It is striking to realize that the very laws that trap us inside this cosmic black hole are the same laws that made our existence possible. The collapsing stars that birthed black holes also seeded the cosmos with heavy elements, the building blocks of planets and people. The expansion that pushes galaxies beyond our horizon also allowed the early universe to cool and form the structures that cradle life. Even the darkness itself, the silence beyond our reach, is the backdrop against which our tiny spark shines brighter. We are children of this universe, not in spite of its vast indifference, but because of it. So when we describe ourselves as dust inside the belly of a cosmic monster, we must remember that this monster is also our parent. The universe is not merely a prison nor merely a void. It is the cradle that birthed us, the canvas on which life has painted itself, the mirror in which awareness now flickers. In its immensity, it seems to erase us. Yet through our eyes, its immensity is revealed. In this sense, the universe and consciousness are partners. Without one, the other is incomplete. This perspective changes how we see not only the cosmos, but ourselves. If we are the eyes of the universe, then every act of curiosity, every question asked, every truth uncovered, is an act of cosmic self-discovery. When we map the stars, the universe maps itself. When we uncover the secrets of atoms, the cosmos uncovers its own blueprint. And when we reflect on meaning, the universe reflects on the mystery of its own existence. We are not separate from the universe looking at it from outside. We are part of it, the part that thinks and wonders. The darkness that surrounds us is immense, yes, but it is also what frames our light. Meaning is not diminished by vastness, it is sharpened by it. A candle in a brightly lit room is unremarkable, but a candle burning in endless night becomes a miracle. Our awareness is that candle, small, fragile, but astonishingly bright. And so the question is not whether we are significant, but what we will do with the significance we already have. Will we squander it turning inward, only to destroy ourselves? Or will we honor it, recognizing that in each of us resides a rare and delicate thread of the universe's own self-awareness? The choice matters because we matter. Against all odds, against the weight of darkness, life has arisen, and with it, a voice. What we say with that voice may be the only story the universe ever tells of itself. From here, we might begin to ask a deeper question. If indeed we live inside a black hole, if our universe is cradled within darkness, then how would this realization reshape our philosophy? How would our understanding of existence, of purpose, of destiny itself change if we truly accepted that? Our entire cosmos is suspended inside a prison of space-time. Would we despair at the thought of being forever trapped? Or would we discover new meaning in knowing that even in confinement, the universe has found a way to awaken? If everything we have ever known, every galaxy, every star, every breath of air, every dream, every memory, truly exists inside a black hole, then what does freedom mean? The very word begins to shift under our feet. We usually imagine freedom as the absence of constraint, the ability to go beyond limits, to move endlessly outward into a universe without walls. But if the universe itself has walls, if it is sealed by a cosmic horizon that nothing can escape, then freedom is not about breaking boundaries, but about how we live within them. We become like fish in an ocean vast beyond comprehension, never realizing that the ocean itself may be inside a bowl. At first glance, this idea seems suffocating. For centuries, humanity has told itself stories of boundlessness. We looked up at the night sky and thought it was infinite. Then we invented telescopes and realized that the stars were suns like our own. We thought that was infinite too, until we discovered galaxies and then superclusters and then the observable universe. Every time we found a boundary, we pushed through it, convinced that true freedom lay in reaching what was beyond. But what if this instinct, this hunger to escape limits, is the very thing that blinds us? What if the cage is absolute? What if there is no beyond? In such a case, the philosophical question changes. Freedom ceases to be about outward escape and becomes something more inward. If reality is a sealed chamber, then the meaning of life is not measured by the size of the room, but by what we do inside it. A bird in a cage is not free in the physical sense, yet its song is still real, still beautiful, still meaningful. Likewise, if the universe is a box, then all of our discoveries, our art, our love, our triumphs and tragedies are not illusions. They are real because they are experienced. This line of thought forces us to revisit one of the oldest philosophical debates. What does it mean for something to be real? Is reality an objective state independent of our perception, or is it something that acquires meaning only through experience? If our universe is trapped inside the event horizon of a black hole, then we may never access what lies beyond it. Does that make our world less real? Or does it mean that reality is simply defined by the horizons we inhabit? Consider a dream. Inside a dream, we can walk through cities, speak with friends, feel joy or fear. While we dream, it feels entirely real. Only upon waking do we realize its boundaries. Now imagine that our entire universe is like such a dream. There may be no waking up, no vantage point from which to see beyond the cosmic horizon. But does that invalidate the experiences inside? To the dreamer, the dream was real. To us, life inside the black hole is real. Reality then is not measured by escape, but by immersion. In this light, the very idea of freedom changes. True freedom may not be the ability to go anywhere, but the ability to make meaning anywhere. If we are inside a box, we still choose how to live inside it. We create, we love, we seek knowledge, we imagine possibilities. The walls do not erase the significance of what happens within them. In fact, they may even heighten it. A painting gains its power from the canvas that contains it. A symphony is meaningful because it has a beginning and an end. Perhaps the boundaries of the universe are not limitations, but frames giving shape to our existence. There is also a subtle irony here. For millennia, philosophers have asked whether the universe has meaning. Yet if it were infinite and boundless, perhaps meaning would be harder to find. Infinity dilutes purpose, stretching it thin across endless possibilities. Boundaries, however, create focus. Mortality, the ultimate boundary, is what gives life its urgency and beauty. By analogy, the cosmic horizon that seals our universe may serve a similar role. It is not there to mock us, but to give context to our story. Still, the thought that we are enclosed inside something larger raises a kind of existential vertigo. It is one thing to imagine our universe as vast and endless, another to think of it as contained. The idea of a cosmic cage suggests that our notions of progress and exploration may always be incomplete. We imagine ourselves as pioneers venturing outward forever. Yet perhaps we are like sailors exploring a vast ocean that is nonetheless finite. Our sense of infinity may be nothing more than the illusion created by our inability to reach the walls. And yet is that so different from the human condition itself? Each of us is finite. Each life is bounded by birth and death. We live inside a personal horizon we cannot escape. And still within that span we find love, build civilizations, create stories. We do not need immortality to give our lives meaning. In the same way, the universe does not need infinity to be meaningful. Meaning emerges inside the limits, not beyond them. This idea also casts new light on the notion of destiny. If we are enclosed, then perhaps our task is not to escape, but to understand. The cage is not a prison to be broken, but a mystery to be explored. And exploration does not lose its worth simply because it is finite. In fact, finitude gives exploration its poignancy. We cannot see everything, so what we do see becomes precious. We cannot live forever, so the days we have matter more. In this sense, the cage does not diminish us, it magnifies us. Philosophers might argue that this perspective makes freedom internal rather than external. It shifts the question from, "What can I escape?" to, "How shall I live within?" A finite universe, like a finite life, becomes an invitation to focus not on endless horizons, but on depth of experience. To love more deeply, to understand more carefully, to savor more fully. That is a kind of freedom that no boundary can take away. And so when we imagine ourselves trapped inside a black hole, the terror begins to soften. Instead of a prison, it becomes a home. Instead of a cage, it becomes a stage. All of history, all of science, all of philosophy, all of art is part of the play unfolding within these walls. The meaning of the play does not depend on whether the stage has an exit. It depends on how the actors live their roles, which brings us full circle back to the paradox with which we began. We long to escape, to push beyond, to break the seal of reality. But what if reality itself is the seal? What if there is nothing beyond? Then perhaps escape is an illusion, and the true wisdom lies in recognizing that we already inhabit the totality of what exists. The black hole is not something to flee, but something to embrace. It is not the end of freedom, but its redefinition. And here is the final twist. In trying to flee the boundaries of the universe, we may overlook the fact that the boundaries themselves give rise to meaning. In searching for an exit, we risk missing the beauty of what lies within. The paradox is that we yearn to escape a place that may in fact be the entirety of reality, the very womb of existence itself. Perhaps the question is not how to leave, but how to live knowing that the whole of the cosmos, in all its mystery and wonder, may be nothing less than home. Perhaps the most humbling truth of all is that we may never know for certain whether we live inside a black hole. The universe does not hand out answers easily. It hides them behind equations we struggle to solve, phenomena we can barely measure, and distances so vast that even light, the fastest traveler we know, cannot bridge them in a human lifetime. This uncertainty is not a flaw in our understanding, but the very condition of existence itself. It is the silence that lingers after we ask a question too large, the mystery that resists being pinned down. And in that silence, in that resistance, there is a strange kind of beauty. Think of what it means to stand under a night sky. The stars above us shine with a brilliance that feels eternal, and yet we know they are mortal, burning themselves out across unimaginable spans of time. When we look at them, we are not even seeing them as they are, but as they once were, their light traveling across eons to touch our eyes. That simple act of looking upward already collapses the certainty of reality. Are we seeing the stars themselves, or only their ghosts? Are we seeing the universe stretching outward into infinity, or the inner walls of a vast cosmic chamber we cannot escape? The night sky becomes a mirror of our ignorance, and yet also a canvas for our imagination. It is tempting to think of knowledge as a ladder, each discovery taking us one step higher, bringing us closer to a final truth. But perhaps truth is less like a ladder and more like a horizon. No matter how far we walk toward it, it recedes always just out of reach. The horizon defines the shape of our world, but never lets us cross it. In the same way, the possibility that we live inside a black hole may never be proven or disproven. It will remain a horizon, thought, a question that shapes our understanding without ever yielding an answer. And this, in its own way, is a gift. If every question had an answer, if every mystery could be resolved, then wonder itself would vanish. Science thrives not on certainty, but on curiosity, on the willingness to lean into the unknown. Philosophy thrives on the gaps. Science cannot fill turning unanswered questions into reflections on meaning. Imagination thrives on the darkness between the stars, filling it with stories of other worlds, other lives, other possibilities. Uncertainty is not a failure. It is the soil from which these things grow. When we imagine ourselves as inhabitants of a cosmic prison sealed within the walls of a black hole, we might first feel despair, but slowly another perspective emerges. The very fact that we can ask this question, that we can imagine this possibility, already gives it meaning. The universe may be indifferent, but our curiosity makes it luminous. Whether or not the walls are truly there, we live as though the act of asking transforms them into something more than barriers. They become the edges of a great mystery, and to stand at the edge of mystery is to feel alive. Perhaps this is what it means to live with cosmic humility. We acknowledge that we are small, that we are uncertain, that we may never hold the full map of reality. But instead of shrinking from that truth, we embrace it. Our smallness becomes a kind of strength because it allows us to wonder. A being that knew everything would have no need for wonder, no reason for awe. To be small is to be open, to be capable of surprise, to find joy in discovery. In this way, science, philosophy, and imagination are not separate pursuits, but threads of the same fabric. Science asks, how does it work? Philosophy asks, what does it mean? Imagination asks, what if? Together they weave a way of living within uncertainty that does not demand resolution but revels in possibility. To stand beneath the stars and ask whether we are inside a black hole is not merely an act of science or philosophy, it is an act of imagination. It is a gesture of the human spirit refusing to settle, for the visible always reaching toward the invisible. And so we come to the quiet conclusion of this long journey through darkness. We may never know the answer. The equations may remain undecided, the observations forever incomplete. The walls of the universe, if they exist, may never reveal themselves to us. But the act of wondering, of asking, of reaching, already changes everything. It makes the darkness less empty. It makes the silence less cold. It turns the unknown into a companion rather than an enemy. The next time you find yourself under the night sky looking into that ocean of darkness, remember this. You may feel small, you may feel like a single flicker in an endless void, but it is precisely that smallness that gives your awareness weight. The stars do not know they shine. The galaxies do not know they turn. The black holes do not know they devour. But you know. You see. You feel. You wonder. That is what makes all the difference. Perhaps the universe does not care whether we are inside a black hole. Perhaps it will never whisper the answer. But in another sense, it already has whispered something in the fact that we are here asking. The darkness has spoken through us, and the message is simple. The meaning of existence is not found beyond the walls, but within the act of seeking itself. So if one night you tilt your head back and feel the weight of the cosmos pressing down, if you sense the possibility that you are caught in something vast and unyielding, do not despair. Instead, remember that your smallness is not a flaw, but a wonder. It is what makes you capable of awe, of love, of curiosity. And perhaps that is the truest freedom of all, not escaping the box, but finding meaning inside it. The universe may or may not be a black hole. We may or may not ever know. But the journey of asking, of imagining, of whispering back into the dark, is itself a kind of answer. And maybe, just maybe, that is enough.